If you haven't already done so, please print off this handout before proceeding. We've already talked about single displacement and double displacement reactions, but now we're just going to get into a little more detail about them specifically. One thing to remember is that for single and double displacement reactions, the reactions are taking place dissolved in water, which means the reactants are aqueous. And here I have a picture showing you what a single displacement reaction looks like. We have a single element displacing another element from a compound. The result is you have another element being produced and a new compound being produced. So normally, one metal replaces another metal in an ionic compound. So the first metal is an element all by itself. The second metal is part of a compound. Now down here I've made a note about hydrogen. Hydrogen can sometimes act as a metal in this case. So you might see hydrogen being in an acid or in water, and the hydrogen being replaced or displaced by another element. Now, just because you add a metal element to an ionic compound, it doesn't always mean that a reaction is going to take place. So we need a way to know whether or not a reaction will take place, and that's where we use the activity series. The activity series of metals helps us figure out if a single displacement reaction will take place. So I say right here to refer to the activity series on your reference sheet. So you should have that in front of you as we proceed. This is what I'm talking about. This is your reference sheet, and the activity series of metals is down in the left-hand corner. So remember, the way we use this is we look up the two metals, and if the metal that's an element is higher up on the activity series than the metal that's in the compound, then the metal element will displace the other element. So let's do an example. If you go back to your handout, let's take a look down here. Example 1. So we're wanting to know if a reaction will take place between copper and iron 2 sulfate. So my two metals are copper and iron. So find both of those metals on the activity series, copper and iron. So here's copper and here's iron. Copper is lower on the activity series than iron, so copper is not reactive enough to displace the iron. So copper is not reactive enough for a reaction to take place, so we'll simply write NR, no reaction. The next reaction is between zinc and iron 2 sulfate, so you have to look up zinc and iron. Those are our two metals. If you look them up, you'll notice that zinc is higher on the list than iron. That means zinc will displace iron. That means our products are going to be iron all by itself and zinc sulfate. And we can of course write this as a skeleton equation. Check your balancing. This one's already balanced. And then we can add our states. So zinc, if it's just a metal by itself, it's going to be solid. And the compound, iron sulfate, it's going to be dissolved in water. So it's aqueous. On the product side, iron, it's a metal all by itself, so it's solid. Zinc sulfate, that's an ionic compound, it's dissolved in water. Now down below there's a question, can I use magnesium instead of zinc to extract iron? So the proposed reaction would be magnesium plus iron 2 sulfate. So to see if you can use magnesium instead of zinc, you would, of course, go back to your activity series, look up magnesium and iron, and see which one is higher up on the list. So magnesium is higher on the list. That means this reaction will proceed. And your products will be iron and magnesium sulfate. Why don't you go ahead and pause the video and try to write the balanced equation with states. So there you go. Magnesium solid plus aqueous iron sulfate makes solid iron and aqueous magnesium sulfate. You can proceed to try the practice questions on the back of the handout.